Okay, let's start. Okay, ang topic natin ngayon ay about diode biasing, part 1. Ano ba yung matututunan natin sa topic na ito? We will learn how to calculate the current and voltage with different diode configurations. We will familiarize use of equivalent circuits to analyze series parallel or series parallel diode networks. Okay, ano ba yung mga tips ko muna kapag mag-solve tayo ng circuit problem? First tip or tip number 1. Determine muna natin if the diode is at forward or reverse condition. Siyempre, kapag forward condition ang diode, ibig sabihin naka-close yung switch at meron tayong threshold voltage. Kapag naman naka-reverse condition, naka-open yung switch at walang current flow. Tip number 2. Check diode's threshold voltage. Ano ba yung diode na ginagamit sa circuit? Kung ideal diode ang nilagay, ibig sabihin, it acts like a switch. 0 volts or wala. Pag silicon, 0.7 volts. Pag germanium, 0.3 volts. Pag gallium arsenide, 1.2 volts. Check if the diode applied voltage is enough for the diode to conduct. Tingnan din natin yung applied voltage. Mas mataas ba siya sa threshold voltage? Or baka naman hindi yung applied voltage natin hindi kayang mag-turn on ng diode. Okay, tingnan natin yung mga example diode circuit problem. First problem, determine the output voltage and the current across the resistor and diode. Okay. So, kung titingnan natin, may 12 volts tayo at ang diode natin dito ay naka-forward bias at ang diode natin ay silicon, meaning meron tayong 0.7 volts na threshold voltage. Dahil ito ay forward bias, meron tayong current flow. So, pwede natin i-compute to through conventional current flow. 12 volts minus yung voltage drop dito, 0.7 volts minus voltage drop dito sa point na to, which is this one, output voltage is equal to 0. So, kapag kinompute natin to, ilipat natin si output voltage dito, makakompute natin output voltage is 11.3 volts. Paano naman yung current? So, ganun din ulit. 12 volts minus 0.7 volts minus, ikot lang tayo dahil para makompute natin yung current. Again, kapag naka-series at wala namang component dito, yun ay same ang current nila na nagfo-flow. Minus, through Ohm's law, ano ba uli ang formula ng voltage? Voltage is equal to current times resistance. Kaya kung lahat ito ay voltage minus current times resistance, voltage pa din yung makukuha mo. Pero this time, wala tayong given current, pero meron tayong 5 kilo ohms na resistor is equal to 0. Kapag kinumpute natin to, ang makukuha nating current is equal to 2.26 milliampere. And sabi ko nga kanina, kapag series configuration, it has same current. Kaya yung current at diode natin is equal to current at resistor is equal to 2.26 milliampere. Nangyayari lang yan again kapag naka-series at walang mga component na nakakonect or nakaparallel sa ating mga component dito. Next, determine the output voltage and the current across the resistor and diode. Check natin, 9 volts. Silicon yung diode, kaya naman niya mag-on. Pero, naka-reverse bias yung ating diode. Kaya, it acts like a open switch. Kaya yung output voltage natin ay 0 volts and yung diode current and resistor current natin ay 0 ampere dahil walang current flow. Next, Determine the output voltage and the current across the resistor and diode. This time, given naman ay 2 diodes. Meron tayong 9 volts, meron tayong silicon, at meron tayong germanium na diode. Both of them are forward bias. So, both of them are at on state. And, pwede na natin computein ang Vout. Same process, 9 volts minus 0.7 minus 0.3 minus yung point dito minus Vout or output voltage is equal to 0. Kapag kinompute natin ang output voltage, makukuha natin ay 8 volts. Again, paano naman yung current? Yan, palitan natin. 9 volts minus 0.7 volts minus 0.3 minus yung Ohm's law na current times resistance I is not given, and 4K is our resistance is equal to 0. Kapag kinompute natin yung value of I, we will get 2 milliampere. Again, wala naman tayong nakaparallel na component. The circuit is series. Series configurations has same current. Kaya yung ID1, ID2, and IR is equal to 2 milliampere. Another example, determine the output voltage and the current across the resistor. Dahil ito ay naka-forward bias, pero ito ay naka-reverse bias, ibig sabihin, open yung switch dito. Kapag open ang switch, walang current flow na dadaan dito. Kaya yung output voltage natin ay 0 volts. At dahil walang current flow, yung current at diode 1, diode 2, and resistor is equal to 0 ampere. Next, determine the output voltage and the current on diodes and resistor. Okay. So, i-determine naman natin. Parallel configuration has same voltage. Tandaan natin, pag parallel configuration, they have same voltage. So, tingnan natin, 12 volts. Dahil ito ay parallel configuration and both of them are forward bias and both of them are silicon, ibig sabihin, isa lang yung voltage na dumadaan sa kanila, 0.7 volts. Kaya iisahin na lang natin sila dahil pares naman sila ng voltage. Kaya 12 volts minus 0.7 volts minus output voltage is equal to 0. Kaya yung output voltage natin sa circuit na ito ay 11.3 volts. Again, wala naman nakaparallel dito. So kapag kinompute natin to, naka-series pa din lahat. Kaya 12 volts minus yung parallel voltage nito na 0.7 minus 4K times current is equal to 0. Kapag kinuha natin yung value ng current is equal to 2.825 milliampere. And yung current nito ng dalawang diode is equal to the current of resistor is equal to 2.825 milliampere. Pero, lagi mo tandaan, kapag parallel configuration, same yung voltage, pero they are different in current. Dito, kapag parallel, ginagamitan ng current divider. Pero dahil equal naman sila sa 0.7, hatiin na lang natin yung current sa kalahati, sa dalawa. Kaya yung current at D1, current at D2 is equal to 2.825 milliampere over 2 is equal to 1.413 milliampere. Ginagamit lang yung paghahati sa dalawa kapag same lang naman yung value ng kanilang component. Okay, so yan, nakuha natin yung output voltage, yung current ng resistor at current ng diode 1 and diode 2. Next naman, we will determine the output voltage and current on diodes and resistor. Okay. So, ganun pa din. Dahil ito ay naka-series, series, dahil wala namang nakaparallel dito sa part ng Vout, same lang yung current nila dahil sila ay in series configuration. Kaya 10 volts minus current times 1 kilo ohms minus 0.7 volts minus 4K times current is equal to 0. Kapag kinompute natin yung current is equal to 1.86 milliampere. Dahil sila ay series, magkakaparehas lang yung current nila. Current at 1K is 1.86 milliampere. Current at diode is 1.86 milliampere. And current at another resistor is 1.86 milliampere. Okay, so makocompute na natin ngayon yung output voltage. 10 volts minus current, ano yung current natin? 1.86 times 1 kilo ohms minus 0.7 volts minus output voltage is equal to 0. So, minus output voltage daw is equal to 0. So, kapag nag-multiply si resistance at current, we will get the value of in voltage. Kaya 10 volts minus yung value nito in voltage minus 0.7 volts minus Vout is equal to 0. Makakompute natin sa output voltage is equal to 7.44 voltage of volts. Okay, determine the output voltage and current on diodes and resistor. This time, yan, meron ng naka-parallel. So, series configuration pa din tayo dito. Kaya 8 volts minus current times 3 kilo ohms minus 0.7 volts is equal to 2.43. Ang current natin is equal to 2.43. Kaya kung 2.43 yung current natin dito, nakaparallel silang dalawa and same lang naman yung value ng voltage nila, yung current across this diode na 2.43 ay mahahati sa dalawa, total same lang din naman yung value nila. So 2.43 milliampere divided by 2 is equal to 1.215 milliampere. So pwede na natin makompute yung Vout natin dito. So 8 volts minus current natin na 2.43 milliampere times 3 kilo ohms minus yung node natin dito na Vout or output voltage is equal to 0. So, output voltage natin is equal to 0.7 volts. Next, determine the output voltage and current on diodes and resistors. Kung mapapansin natin, both of them are silicon. 0.7 volts ang kanilang threshold voltage. Pero, ang kanilang supplied voltage o applied voltage is positive 5 volts and 16 volts. Ang rule dito, yung mas mataas ang potential o higher potential, sila yung mas unang magko-conduct or magko-conduct. Kaya, dahil itong higher potential, magko-conduct ang part na to, at itong lower potential, it will remain at open condition or off state. Dahil off state siya, ito lang ang mako-compute natin. Okay, so compute natin yung higher potential na nag-conduct. 16 volts minus 0.7 volts minus yung point na to, Vout is equal to 0. So, Vout natin is equal to 15.3 volts. Para ma-compute naman natin yung current, kapag dinire-diretso natin yan, wala naman tayong components na madadali, kaya series configuration yan. At ito naman ay naka-off, kaya walang current flow dito. Kaya itong part na to ay naka-series configuration, at kapag series, they have the same current. Kaya 16 volts minus 0.7 volts minus current times 6 kilo ohms minus negative 3 volts. Ganan mag-compute, ha? Minus negative 3 volts is equal to 0. Kaya, ang makukuha natin current is equal to 3.05 milliampere. Current at D2 is equal to current at resistor is equal to 3.05 milliampere. Ano na yung current sa D1? Dahil siya naka-off or naka-open yung switch, ang current niya ay naka-0 milliampere. Okay, next. Determine the output voltage or voltage across the resistor and current on diodes and resistor. So, marami tayong kukunin. So, series configuration. Wala naman akong component dito. Naka-series lahat sila. Kaya, pag series configuration, same lang ulit yung current. 16 volts minus 0.3 volts minus current times 2 kilo ohms minus 0.7 volts minus current times 5 kilo ohms minus negative 8 volts is equal to 0. Kapag kinumpute natin yung current sa equation na to, we will get 3.286 milliampere. Dahil yan ay naka-series, pare-pares lang yung current nila. Current at germanium is equal to current at silicon, at current at 2 kilo ohms and current at 5 kilo ohms of 3.286 milliampere. And let's get the output voltage. 16 volts minus 0.3 times yung current natin, na-compute na natin, 3.286 milliampere times 2 kilo ohms times, minus V out is equal to 0. Kaya ang V out natin is equal to 9.128 volts. At yung voltage at 2 kilo ohms and voltage at 5 kilo ohms, makakompute na natin yung true Ohm's law. 2 kilo ohms voltage is equal to 2 kilo ohms times yung current daan sa part na yan, 3.286 milliampere is equal to 6.572 volts. At ganoon din sa 5 kilo ohms voltage is equal to 5 kilo ohms times 3.286 milliampere is equal to 16.43 volts. Okay, dito na tayo sa medyo challenging. Okay, pero huli na ito. Determine the output voltage or voltage across the resistor and current on diodes and resistor. Kung mapapansin natin, pares naman silang may diode. Pero, this time, magkaiba yung resistance nila sa kada circuit path at nakaparallel pa sila. Kaya, ang mangyayari, kukunin natin yung current flow sa path na to at yung current flow sa ibabang path. Okay, kunin natin 12 volts minus 0.7 volts minus 2K times, dahil dito ang current dito is ID1 o I1, pero i-rename natin na ID1 times ID1 minus, this time dahil parallel siya, may current dito na ID1 at may current dito na ID2. Kapag nag-combine sila sa node na to, ID1 plus ID2, kaya ang current dito is ID1 plus ID2. Okay, kaya 2K times ID1 minus 1K times ID1 plus ID2 minus negative 9 volts is equal to 0. Kapag in-arrange natin yan, we will get 3 kilo ohms times ID1, dahil wala pa tayong value, plus 1 kilo ohms times ID2 is equal to 20.3 volts. Okay. Hayaan muna natin yung equation 1 na ganyan. Let's go to equation number 2 for our ID2. 12 volts minus, sa baba naman tayo, 0.7 volts minus 4 kilo ohms times ID2 minus 1 kilo ohms, dahil nga nag-combine silang dalawa na ID1 at ID2 sa node na to, napunta sa part na to. Kaya 1 kilo ohms times ID1 plus ID2 minus negative 9 volts is equal to 0. Ang makukuha natin equation is 1 kilo ohms times ID1 plus 5 kilo ohms times ID2 is equal to 20.3 0.3 volts. Okay, so meron tayong two equation, two unknown. So pwede natin itong ma-solve through substitution or elimination. Okay, ang tinaray ko dito ay through substitution method. Ayan. After ko mag-substitute ng ID1 papunta dito para ma-compute ko si ID2 and para ma-compute ko din si ID1. So, kung paano mo siya ginagawa, basta ang process dyan is through substitution or elimination. Ang nakuha kong ID1 is equal to 5.8 milliampere and yung ID2 ko is 2.9 milliampere. Again, ano yung current ng IR? Yun ang pinag-add na ID1 and ID2. Para ma-compute natin si IR is equal to ID1 plus ID2 is equal to 8.7 milliampere. Paano naman yung Vout? So, pwede na natin ma-compute. In either direction, makukuha mo ang Vout. 12 volts minus 0.7 volts minus 2K times ID1. Ano yung ID1? 5.8 milliampere minus yan minus Vout. Okay, but may ganito pa dito. Yan. So, minus Vout is equal to, ayan, compute natin. Check natin kung tama yung nakuha natin. Ang output voltage natin is equal to 5.5 volts. Yan. Ganan ang pag-compute ng mga circuit problem ng diode. Okay, pa-check na lang ito. Kung mali man, isi-send ko na lang yung tamang sagot dito. Kung mali man yung na-compute ko dito sa part na to. Okay. So, sa activity nyo, yan, gawin nyo. And send nyo na lang on October 3, 6 p.m. Okay, thank you and good luck.